Vectors 9.2 Systems of Linear Equations in R2. So in this chapter we'll understand systems of linear equations basically in R2, that means 2 dimensions. So we'll deal with two variables x and y. Consider the system of equations x plus ay equals to 6 and x plus 3y equals to b. Determine the values of a and b for which the system of equation has no solution, one solution, and infinite solutions. So this is an excellent example to start with. It kind of explains the whole thing, right? So we are very conversant with lines as such. And here we are with two familiar linear equations. So let me write them down for you clearly. So one is x plus ay equals to 6, and the other one is x plus 3y equals to b. Now we have to look for the values of a and b which can transform the equation so that you can have infinite number of solutions, one solution, or no solution, right? It's good to see everything from both sides. So I normally start with the right side. Now as you can see here, infinite solution means what? Infinite solution means that the lines are same, right? Exactly same. We say coincident, right? So that means infinite solution. They're exactly same line, so there is no difference between the two lines. Their equation should be same in that case, right? Coincident, right? In that case, they have infinite solutions. So these two lines can be same under what condition? If a is 3, for example, let us say if a equals to 3, and if b is 6, then they're exactly same lines, correct? Then the first line will be x plus 3y equals to 6, and the second will be x plus 3y equals to 6, right? Exactly same lines. So if they are same lines, they will intersect at each and every point, correct? And so they will have infinite solutions. That's it. So that's how we understand these lines. Now let me plot and show you here. So what do we have here? If I write 3 for a, then basically the lines which we are dealing with will be x plus 3y equals to 6, right? Now to sketch this line, I just need x and y intercepts. So if I put y as 0, x intercept is 6. Let's say 6 is somewhere here. And if I put x as 0, then the y-intercept will be 6 divided by 3, which is a number 2, for example, right? So let me draw a line first and then we'll write down the intercepts. That's easier for me. So that's a line, for example. Okay, good. Now this line is not that bad. Now here is my y-intercept, and the y-intercept should have been 2, right? So we'll write 2 here. And the x-intercept is 6, so that is the line. And both lines are same if we write a as 3. So the first one becomes x plus 3y equals to 6. If we write b as 6, the second one becomes x plus 3y equals to 6, right? So basically both of them are exactly same lines, correct? So they intersect at each and every point. Such lines are called coincident lines, right? So I'll introduce you to one more term here, and that is, we'll say we have a solution indeed. So we have a solution, maybe infinite number of solutions, but we call them consistent system. Consistent system. So we say the system is consistent as it does have a solution, right? And the solution is infinite number of points, correct? So it is a consistent system and the lines are coincident. That is what we learned now. Now let's get to the very first thing, which is no solution. Now, so the two lines were really overlapping, right? One over the other, so we have just drawn one, right? So we know exactly that both are same. Now if I change my y-intercept, for example, move it a bit above or lower, then they become parallel lines. Isn't so, right? Yes, it is. So what we will do here is we will straight jump to no solution scenario. So no solution scenario is like this. So we do have a line here which is same. One of them will maintain same. Let us say the first one. So we do have a line here which has a y-intercept of 2 and x-intercept of 6, right? So let us say the first line we maintain same, that is x plus ay equals to 6, where a is equals to, we have taken a value of 3, right? So that is my first line. But the second line, we don't want it to be same. So then the condition should be x plus 3y, where is equals to b, where b is not equal to 6. Do you see? B is not equal to 6. If b is not equal to 6, it is something else. In that case, the lines will be different. You get the point, right? So, if b is more than 6, for example, if b is 8, for example, or 9, for example, then this point will be above. So we have a parallel line. So the other line will actually be starting from here and move like this. So that is, I'm taking b as greater than 2. Then it will be above this line. Rather, b is greater than 6, right? So the y-intercept will be more than 2. So that becomes the other line if b is greater than 6. If b is less than 6, then we may have a line below this. But they are parallel lines. What I'm trying to say is these are parallel lines. And since they are parallel lines, they will not have any solution, right? So in this case, we say that the lines are distinct, right? So we have distinct lines and they are parallel, same slope or direction. And since they have no solution, we will call this system as inconsistent. It's very important to understand these terms. At times in the test, they may just ask you whether the system is consistent or not. Now, if you don't understand what is the meaning of consistent, then how will you answer the question, correct? So we got two scenarios here already, and that is when a is equal to 3. In that case, we have two possibilities. Whether we can have infinite solution or no solution, depending on value of b. If b is 6, then we have infinite solution, and if b is not equal to 6, we have no solution, right? So that is what we have. And now we are left with one solution scenario. The two lines, if they intersect, and if they are not coincident, in that case they intersect only at one point. And for that, what is the condition? The condition is very simple, and the condition is that a is not equal to 3. If a is not equal to 3, lines are not parallel. That is simple. And these two lines are in the same plane, right? They are in the same plane. So they are coplanar. So they will intersect, and they will intersect in just one point. So depending on what the value of a is and what the value of b is, you will have intersection of lines, and in that case, we can draw like this, that a is not 3 for us, so b could be anything, right? So we'll maintain the other line here, let's say this, right? And a could be anything, therefore we can draw any other line, let us say like this. As you can see, it will always intersect just in one point. So this is the case when a is not 3. That means the direction of the line is different from what is shown here. If it is not this direction, then it will, if it is any other direction, it will intersect this line at a point. So that is what we are trying to understand from this particular example. So this example was kind of simple since we had, proportionate kind of a thing here. So we'll take another one where we'll shift these constants to a different position and make it slightly more complicated, and then analyze the same system and find out the values of those variables. What should those variables be so that we get no solution, one solution, or infinite solutions. Important thing here which you've learned is that when we are talking about two lines, then there are three possibilities. That is, they intersect, and if they intersect, we say that the system is consistent and we have a solution. So there is a solution where we have only one solution, that means they intersect at one point, or we could have infinite number of solutions since the lines are coincident. And the third scenario is that the lines are parallel and not coincident. In that case, we have no solution at all. So these are the three possibilities. So if the system is inconsistent, then that means that the lines are parallel and distinct and they have no solution. If the system is consistent, there are two possibilities, right? This is also consistent system, right? Consistent. And we have one solution. The lines are distinct, right? So we have distinct lines. So these are the different scenarios, and we'll have more problems to solve so that we understand this topic better. Let's move on. Thank you.